All right, so an important concept here, specific gravity. That's a lot to write down, so very often it's abbreviated SP and GR. But specific gravity basically takes the density of a material and compares it to the density of water. And so it does this as a ratio, so it's set up in a fraction. And if the answer is less than 1, then you have an object that is floating. So I expect this to be less than 1. If it's exactly equal to 1, then technically it matches the density of water, and if it's more than 1, the object will sink. Now, if you have a uniform object, then it's easy to see by the way it's floating how its density compares, and you can actually use that to directly find specific gravity. So in this case, the way it floats, basically the ratio of what's underwater to what's over water, um, will help us find specific gravity. So if I can find little h, which remember comes from just the part that's underwater, and I can divide by the full height of the crate, that helps me find that ratio of how much is underwater, and it helps me compare my densities. So capital H is ready. I already have the full height of the crate. What I don't have, again, is how much is underwater. And we see a similar trap with this one, that if I try to set this up and go find the difference, that my centimeters, is a big number. It looks like it's going to turn negative. Also, we can't subtract different units, so we've got to go and fix this first. And similar to before, 100 centimeters makes 1 meter, so 0.2263 meters. That's not little h, that's the part that we need to subtract away. So be careful not to jump in a hurry and grab that number. But here, once we can find the difference, we can find the part that's underwater. It's 1.1237. Then we have everything we need we can plug in. So the little h is the thing we just had to work and find. Then the capital H is the full height of the crate, which has been sitting in the question the whole time. The units are going to cancel. So meters and meters are going to go away. A little bit of trivia. The density here will always be the same value as the grams per milliliter version of the density. All right, but dividing these, we get 0.8324, which is less than 1 like we wanted, so it makes sense.